This is a presentation about the importance of entropy in AP Chemistry. Entropy is a basic concept, but it's also a very, very important one. You can simply describe entropy as the disorder of a molecule. The more disorderly it is, the more likely it is to react into its products. Put simply, entropy is higher when the molecules are sloppier and messier. For instance, you can look at the room of a lawyer or a diligent parent. Everything's in order. They know where everything is. There's no entropy to be found here. But if you look at the room of their child, it's a completely different story. There's clothes everywhere, probably some moldy pizza under the bed, garbage, wires, it's a mess. It's very sloppy, and there's no order to be found. That is high entropy. There are many things that affect entropy, but the particular big kahuna would be the state of matter. For instance, let's look at this crystal lattice of a salt. There is no entropy here, or at least very, very low entropy. There's never truly zero entropy. These are only vibrating against one another. There's no free movement whatsoever. They're stuck in position. All they can do is vibrate. There's not much motion. It's very orderly. There's no disorder. This has very low entropy. Then if one were to look at a molecule of H2O in the liquid phase, you'd see it moving, because liquid water isn't stuck in formation like a crystal lattice. Thus, it has higher entropy, but it does not rival the amount of entropy present in an O2 molecule, as seen here. Molecules of gas have free movement within their container. That indicates an extremely high amount of disorder, or a high amount of entropy. Moles matter as well. For instance, let's look at this reaction between N2O4 and 2NO2. There's only 1 mole of gas here, but there's 2 moles of gas over here. A gas molecule wants to be high entropy. It wants to be moving about the place, free of any bonds. They don't want order. They want disorder. They want messiness. And as such, at standard temperature and pressure, this reaction will go to the right, towards 2NO2. Additionally, the size of the molecule matters too. The bigger the molecule, the more orderly it is, and the less it wants to remain that way. For instance, this is the baking soda volcano reaction. Any kid who's ever poured vinegar and baking soda into that volcano shape will tell you how vigorously it created this foam of CO2 and H2O. This molecule on the left, which I believe is carbonic acid, is extremely wanting to move to the right, not only because it's going to become 2 smaller molecules, there are going to be 2 compared to 1. And as we previously stated, gases are higher entropy if there's more moles on one side than the other. The side with the more moles has more entropy. And as such, this reaction, as you well know, will move incredibly far to the right. Entropy is a pretty basic concept, but its importance cannot be understated in chemistry and thermochem. If you want to succeed in AP Chemistry, you're going to need to understand this well.